Let's go ahead and take a look at chapter 3.2, multiplying or multiplicative and divisional thinking. Multiplication and division, what we're going to look at. So before we jump into the notes, I want to again point out the textbook and being able to play the interactive component of the video and really listening to how Nathan decides to multiply 6 times 5. And I like to kind of call these, as it says here, moments of brilliance. And as a math teacher, I've taught many math classes where that's what I'm looking for. I'm looking for these moments of brilliance in class that students don't even realize that they're being brilliant. And how do you highlight those? So it's worth definitely playing the video and taking a look at what he thinks. All of that's going to lead into what we call the 3 models of multiplication, which is we think about multiplication as repeated addition. We think about it in a geometric or physical way. We think about a rectangular array model. Again, sounds fancy, but we'll take a look. And then defining multiplication back to our set theory ideas, connecting back to that original idea of sets, the Cartesian product model. So let's go ahead and take a look at the notes for this section. Let me get caught up a little bit. There we go. Zoom in for you. We left off talking about addition and subtraction, and now we're going to make the connection between addition and subtraction with multiplication and division, right? So again, go ahead and play with that idea. Wish we were in class to kind of really have deep conversations, but really interesting. And then take a look at some of my notes here about what he did to do his thing and checking to see, does it always work? And this fundamental question, when he says, what does add a 0 mean? He says that, what does that mean? So let's move on to multiplication as repeated addition. And so we can see here A times B, it's a multiplication problem. Students memorize it. But ultimately what happens is they start to think about it. Where does it come from, right? It comes from repeated addition. It's a shortcut way of doing B plus B plus B A times, right? So that one of the factors is being added that many times together. The B is being added together with A times. That's it. And hence, maybe that's where the times comes from in multiply. 3 times 4. And keep in mind, technically 3 times 4 gives the same answer as 4 times 3, but it technically is represented, a repeated addition model represented as 4 plus 4 plus 4, or 3 plus 3 plus 3 plus 3. So just keep that in mind. Again, the answer is the same, but how are students thinking about it's an important way to conceive how they're doing those problems. Here is, again, how we can do it with the models, set models, like using the objects and then counting them, putting them sets, versus a measurement model where we're thinking about like a ruler or number line where we're measuring them out. So there is, again, 4 groups of 3, right? As we think about that problem. 4 groups of 3. So what would that mean? Again, that would be 3 plus 3 plus 3. So that'd be 4 times 3. So do 3 4 times. 4 times 3. So here again, the models for the first example for repeated addition. Hopefully you got a sense of what that is. So you can pause and write that down. But you probably could have had an intuitive idea about that. Now, just like we did with addition and subtraction, if there are properties for that, then we probably should have some properties for multiplication. We do, right? And again, these rules are not always intuitive. Students take time to learn them. And again, it happens over time. But I'll remind you, it happens over chances to flexibly think about mathematics. Students may ask you, is 9 times 2 the same as 2 times 9? And remember, when they're memorizing multiplication tables, they don't recognize that. They're just memorizing. And at some point, a student will ask you, Mr., Miss, right, are they the same answer? 5 times 4 is the same as 4 times 5? And so that would be the commutative property that says, yeah, they are. And then we have associative property, which means you can mix them around. You can change the order that you do your multiplication and get the same answer, especially with 3. But that can be, we could grow that out to 4 numbers or 5 numbers, right? Distributive property is commonly used in algebra and advanced mathematics, but it starts here. We're going to see some flexible thinking with distributive property, that A times the quantity of B plus C is the same as just multiplying A times B plus A times C. You would get the same answer. Identity property that anything times 1 is itself, and that's what that says here. And then now we have the multiplication of 0. Anything times 0 is 0. Moving to the next two examples, and then we'll see from here where we go. Verify the associative property for these numbers. So here is showing that associative property works. You could change the order of multiplying, get the same answer. Verify the distributive property works, and you get the same answer, right? When we look at how we add 5 plus 7, 4 times 12 is 48, or do 4 times 5, 4 times 7, and you still get the same answer. Where that leads us to is the Wonder Play Grow. Again, hopefully you get a chance to use some thinking strategies. You see the answer here, but hopefully you may have come up with your own thinking strategies, but you could see instead of memorizing or trying to figure out or do an algorithm, which we learn in later sections, 2 times 34, I can do 2 times 30 plus 2 times 4 in my head. So thinking strategies. Even this one here, remember, this is not distributive property. It's not a plus here. So be careful. It's 5 times 2 is 10. Again, changing the order. And then on a C, you could do 7 times 20, 7 times 5. But again, there could be other ways. So I want to make sure you're conscious and aware of that. And then we finish multiplication. Let's pause there and let you think and take that in, because we'll go to Cartesian products. Let me stop the video at this second now.